Dr. Manikandan holds a PhD from London Institute of Technology and a Master of Engineering in VLSI Design from Anna University. He holds various professional certificates like Certified Scrum Master and ISTQB. He published research articles in various international conferences and reputed journals on fault diagnosis and health monitoring in power converters. His research interests include fault diagnosis remain useful lifetime. Estimation of power electronic management of IGBT power modules in electrical drive applications. And now welcome.
Good afternoon, students. Settled. Let's start the session. So, what is the theme of the particular conference? See, it will be interactive one only. It's not monotonic. Okay, I'm not going to share something you are not aware of it. So I'm just going to share the information you have already or you maybe know in different time of your life or you might be undergoing that thing. I'm just compiling the information and putting into some number of slides I am going to share with you. I know what the background of your students. All of you from which background? Electrical, electronics or electronics and communication or mechanical. I would just want to understand what is the audience. All of you EC background or electrical students also here or mechanical students? EC, Triple E, very good. Okay, I am also from Triple E. Okay, I am Bachelor of Engineering from Triple E, Master of Engineering from VLSI Design, that is, it comes under EC department, and PhD from Power Electronics and Drives. Okay, right now I am working in an organization that the motto of the organization is green energy, or you can say clean air. So my company is Albonair India Private Limited. So it's a basically German-based company. Our head office is in German. The Dortmund, head office is Dortmund, Germany. And Albonair means Albo means clean air, Albonair. Okay, clean air. So we are trying to give you the clean air to the society. So what we are doing exactly? We are working with after treatment, exhaust after treatment system. So it is shortly called EATS, EATS, exhaust after treatment system. So I am saying after treatment system means, so where I am doing, where my company's role is. You know, daily you are traveling in a lot of buses. Okay, mainly we are working with buses, and some places in our college also you have a lot of generators. All these are working on what basis? What is the basic principle of this? What is the input to the particular system? Whether it is bus or generator, what is the input to the system? Can anyone tell me? What you are giving as input to the system? How the energy is produced? What? Fuel. What is the fuel? Petrol or diesel? What is that? Buses and generators I'm talking about. What? Yeah, exactly. Diesel. Okay? So, right? So, when we talk about IoT, so immediately what is the thoughts will come. Any examples you will understand in real time where is you are using IoT, Internet of Things. Where you are using IoT in real time. Anywhere in daily life I'm telling. Internet of Things. In day-to-day life we are using. That's what I'm asking. Are you controlling something from your mobile? Are you visualizing something in your mobile? You are controlling your TV or air conditioner in homes using mobiles now? It is easily nowadays controllable. Your air conditioners, all these items, consumable items, easily can be controlled by your mobile because you are connected by internet. Right? That's called Internet of Things. So automated, so many things are automated. So IoT means Internet of Things. In day-to-day life we are using it, and so many industry we are using it. Now the industry, whatever the things we are adapting in the industries, that is manufacturing industries, that has to be adapted to the agricultural industry also. Good. That's what we are going to discuss, and we will see something related to how it is useful in the automotive perspective. Okay. Since I am from the automotive background, so I will touch something related to automotive, something related to electric vehicles, role of electric vehicles in the agriculture sector, right? What are the challenges there? These things we can just things like that we can see. So this is the agenda we are having. We are going to see what is smart agriculture. Then what are the use cases in the smart agriculture? That's the important thing. Okay, where you are using this IoTs for smart agriculture. Then automotive where it is plays the central role. Then telematics. Because nowadays you need not go and see what is the real condition of the particular plant or crops, anything. Using telematics, sitting in your home, you can visualize the condition of the plant, what is the soil nature, what is the what you can say, whether the plant is needed water or not. These things you can easily find out sitting in your home itself. Nowadays we are using lot of drones for agricultural purpose. We are using lot of drones for agricultural purpose. Next, what are the challenges we are facing for off-highway applications, automotive off-highway applications? So here I have a question. What is on-highway, off-highway? What is on-highway, off-highway? Tell me some examples for off-highway vehicles. Anyone? Examples for off-highway vehicles. On-highway means the vehicle which is running on the road. They are called on-highway vehicles. Off-highway vehicles means examples for off-highway vehicles. Tell me. Somebody is telling you can't hear. But
Hey, you can't.
Tractors. Tractors are one of the examples for off-highway vehicle. And all the agriculture related to vehicle, not just a tractor, JCB, construction vehicles. All the construction vehicles are off-highway vehicles only. Bookline, everything is off-highway vehicles. Okay, so we will see what are the challenges we are facing off-highway vehicles when it is to electric vehicle? Because the trend is nowadays electric vehicle. So what are the challenges? Right? Digital agriculture mission. It is the digital agriculture mission is the initiative by central government. So what is this dam? Okay. So this is the agenda. I don't know how much I will complete this, but I will go very slow only. I will interactive only, right? So what is smart agriculture? Whenever you include digital communications like your sensors, actuators, then all the communication technologies. Even if you are using some sensors, we are using data from remote location. If you are accessing the data from remote location, how we are accessing the data remotely? What communication is used? What communication is used for remote accessing of the data? Tell me. That is the agenda of today. What you can say? Conference and all. What communication is used for remote access of the data? How you can be able to access the data remotely? Sensor is the measuring device. It's a reads the information. But how you can be able to access from the remote location in your mobile? Cloud. No, not necessarily cloud. Cloud, how it is working then? What is the communication? Internet protocols. That's the communication you are using. You are using internet protocol. If you are using the data in between two nearby devices, something if you are using Bluetooth, one mobile to another mobile, if there is no internet, there is a Bluetooth communication. Sometimes you can call it Wi-Fi. Wi-Fi also does not need, you can say, internet or LAN communication. Right? Within the board, if you are using, then I2H key communication. In your computers, within the PCB board, we are using I2H key communication. Right? Similarly, for remote sensing, everything we are using internet protocols. Right? So, if you are using this latest technology for the communication purpose, then it is using a smart. And objective, what is the objective? What is the objective of the smart agriculture? Naturally, you want to quality as well as quantity. Both you need to increase. That is the objective. The reason is that since the population is growing, you have to understand one thing in clear. Since the population is growing, population is keep on increasing now. So when the population is growing, so people are constructing more buildings, right? What is it really expanding? Buildings only expanding, not agriculture. Land is not expanding, right? So since the population is increasing, land size is decreasing, but we need to feed for more people. Do you understand what is the challenge in the agriculture sector? Population is increasing, the land size, agriculture land is decreasing, but inversely, number of people to feed it is increasing. Something called food security. We need to check. So that is the objective. That is the main goal. We need to serve to more people. Only it can be achieved. Nowadays it is difficult to get agriculture laborers also. That is also one of the reasons why we are going for smart agriculture. So the technologies are, as I told you, it is IoT, big data, then robotics, drones, as I told you, robotic arms we are using for remove the weeds in the agriculture lands and all. Drones are used for fertilizing purpose. So these are the things we have to adapt to make a smart agriculture. So end of the day, what is we have to focus on? Precision. What is precision? Anyone tell me? It's a common technical word. Precision. What is precision? What is efficiency? What is sustainability? Anyone can tell me what is precision? What is efficiency? It's a common terms, na? Yes. Okay. Okay. Yeah. Precision means when you are going to pick some, because we are using robot arms. We are using robot arms for in the smart agriculture means how precisely it is picking that particular fruit. Okay. How much precisely it is removing the weed in the. So this is what an important part of smart agriculture, precision farming, right? Then efficiency, less input, and we need to get more output. So as I told you, the challenges we are facing in the current scenario is food security. Food security means here underline the protein security. What does it mean? Since say listen everyone, the amount of content I am covering is not matter. Number of slides I am covering does not matter to me. How much I am sharing to you, that does matter to me. Okay, don't see the number of slides, right? How much I am engaging you, that's really important to me. So here I am telling food security, under that protein security. What does mean? Because in our day-to-day life, we are taking more carbohydrate. Do you agree? More carb we are taking. Rice, roti, anything, even bread, whatever thing you go, parota, all are carbohydrate. Less protein involved. Where you can get protein? Eggs only, yeah? Meat. So, cheapest protein, where you are getting? Soya. In my knowledge, if you have some food which is complete, I can say a complete food, it is egg only. You know, egg is having all the things to grow, yeah? What you can say? For life. ஒரு உயிரை உருவாக்குறதுக்கான எல்லாமே அந்த ஒரு இதுக்குள்ள இருக்கு. It has everything. Right? So nowadays, what is the cost of egg? 6 rupees. And desi eggs, not whatever. 13 rupees. It is affordable for everyone. We are choosing. See, myself I am taking only for a broiler egg. The point is that I am talking about protein security means if there is no broiler nowadays, we would have lagging that very much. That you have to understand. This is livestock. So since we are using this all the technologies to have this kind of, and in a 45 days you are having the broilers. You need to have at least 6 months for desi chicks. Similarly, for everywhere we are using technologies to satisfy the human needs. That's what you have to understand. And we have to work against the climatic action and environment. As I told you earlier, we need to have more with less. That's what the ultimate aim of the smart agriculture. We have less land, less human labors. With the help of that, we need to achieve more product or productivity to meet the increasing population. So these are the mega trends in agriculture technologies: sustainability, automation and autonomous operation, reliability, electrification, and Internet of Things and services. So these are the different levels of future systems. Now, farm management system should work as a manufacturing management system. In an industry, how the manufacturing is happening now, the same thing has to be adapted to the agriculture industry also. Then only we can increase the productivity. That's the ultimate aim of this conference, something like that. Okay. Because in our industry, since I am working in the industry, we are processing lot of process, level of process. Similarly, agriculture also we have to follow everything. So that's what I am trying to say. As Mr. Albert Yaro told, agriculture shall be done in the way it being industrial manufacturing system. It has to be done in the way like an industrial manufacturing system. Then only it can meet the challenges or demand of the population growth. So let's see that so many things. Since the population is growing, where the scarcity, resources are scarce. We have limited resources, but the population is growing. So to meet the demand, we need to go for smart agriculture. That's the ultimate aim. So the objective is to help the farmers boost yields. Yields has to be increased. Then reduced, cost has to be reduced. As I told you, it is the objective to help the farmers to monitor the livestock. Livestock means, as I told you, what is the livestock here? The chickens. Chickens are livestock. You have to help the farmers to monitor the livestock, because when you go for this desi chicken, this broiler chicken, there will be which chickens more mortality. Broiler chickens, there will be more mortality. When you are growing this broiler chicken for egg purpose or your meat purpose, you need to monitor the everything, temperature, humidity, everything has to be carefully monitored, because they cannot withstand actual external temperature like our desi chickens can adapt any situation. Why we need to go, as I told you earlier, why we need to go for these broilers and all? To meet the demand. You think about, if there is no broilers, how your protein will be metered? The requirement cannot be met. That's you have to understand. Then most of the people will already have a lot of people sugar problems. Definitely, the next generation will be fully sugar patients. That's the thing. Next, automated irrigation. So automated irrigation means here, whenever you need water, that time only your water will be given to the particular plants. In the olden days, what is happening? In the morning, the farmers will just open the motors. Whether the plant is needed or not, you will just let it give the water. Nowadays, we don't have enough water or enough electricity. So we need to go for automated irrigation. And as I told you, supply chain management. This is the kind of thing industries follows. Supply chain. What is supply chain here? When there is a consumer or customer, whenever you have to understand the demand, so the demand has to be met in a wise way. When the demand is more, you could not supply enough, means you are not meeting the supply chain. When the demand is less, but you have grown a lot of food, then the amount of the you can say demand of your product, like a tomato, suddenly rises, suddenly decreases because the demand is not there. Suddenly onion, the demand is high, means there is no supply chain is properly maintained. That's the reason. The proper supply chain also has to be met. For all these things, this IoT or smart agriculture will be helpful. So nowadays, around 100 million devices already, the farmers are connected with 100 million devices. In the future of 2032, around $32 billion solution will be with IoTs. So, here are certain examples where you are using these IoTs. One is that detecting the weeds and identifying the plant disease, then ripe fruits it is 100%, nothing is can be detected 100%. You can see the percentage. Nothing 100% cannot be detected. But it is more than 80%. In most other cases, it's more than only the water use detection only 50%. That's what the real scenario. The benefits of agriculture IoT is yield increase, resource optimization, environmental impact reductions, and as I told you, food security, labor reductions. These are the primary objective of the IoT or smart agriculture or benefits of the smart agriculture. So these are the different use cases where you are using IoT or smart agriculture. Precision farming. I already told you what is precision. And precision pest control. Always we need precision. We should not kill the pest. That is, there are some species which support the agriculture. Some species which not support the agriculture. So we have to precisely kill those insects or something like that, which support or not supports. Similarly, when you are using, remove the weed. Weed என்னப்பா களை இருக்குது. நீங்க வந்துட்டு உங்களுடைய களையை மட்டும் ரிமூவ் பண்ணணும். பயிரை ரிமூவ் பண்ணக்கூடாது. What is that? That's what you can say precision. Then livestock monitoring. Here livestock means you can say broilers or your goats or your cows, all are livestock only. Okay, so we need to monitor the living conditions. Particularly the living condition has to be properly monitored. Whether they have the enough air, whether they have the enough temperature or over temperature, whether they have yield, everything has to be monitored using those sensors. That's smart irrigation. Whenever the water need is there, we have to give yield monitoring and prediction. Yield monitoring, when we want to remove that yield, that has to be predicted. Then farm equipment monitoring and maintenance, remote operation, supply chain optimization. So I told you these things I already told you. These are just slides only. So we will collect the real world condition, real data conditions that will be collected through the sensors. What are the sensors? Normal sensors. Normal sensors. Temperature, humidity, pressure. These are the normal sensors we will use. Soil moisture. We will check the soil moisture sensor. How much moisture is in the soil? This will help us the irrigation, na? Definitely. So with the help of that, as I told you, irrigation, with the help of that, we can use irrigation system, feeding system, where we have to turn on the fan for a livestock I am telling. If the temperature is increased, turn on the fan. If the temperature is expected, why is the continuously run the turn? Why you need to run the fan in the livestock conditions? That's what the thing. The temperature, as I told you, everything in the slide is already told before. I'm just passing the slides. Then drones. Drones will be used for two purposes. One is for fertilizing purpose. Otherwise, it can be used for monitoring the plants and all. Monitoring purpose also we can use plants, right? This is I told you about livestock. This is plays important role. You like I forgot to tell you milk. I talked only the meat and egg. Milk also playing important role, man. Nowadays we don't have desi cows that will give you 1 liter. Jersey only giving 10 liters. Okay, those jersey will not happily live in a normal temperature like a desi cows. They have to be kept in a conditioned environment that is suitable for them because they are actually from foreign countries. Okay, so that's the thing. These are from greenhouses. Greenhouses means within a shed or something, with a conditioned environment. The condition will be maintained. It's not like outside the world. When the temperature will increase suddenly the temperature like that only na. Today suddenly the temperature is high, next day there is a rain. But the greenhouses, everything will be properly maintained. That's what greenhouses. So yield also very good, because what is the plant needed? What is the condition plant is needed? That humidity, temperature, water, everything will be properly given, properly monitored. Yield also will be more than 95%. That's the thing, na? This is the smart irrigation. Smart irrigation means wherever the plant is there, you don't just spray the water or just like in the olden days, just open the motor and it is going everywhere. It is not the smart way of irrigation. Wherever the plant, only on the plant there will be a spray. Rest of the places no spray of water. This is what smart irrigation. And yield monitoring and protection. Whenever the yield is ready to pick, then so prediction means definitely when I am saying prediction means lot of image processing is also involved. Lot of image processing involved. We cannot just predict whether the fruit is ripe or not. With the help of images only we can predict. So lot of image processing also involved. The farm equipment monitoring and all this maintenance, everything we will. So farm equipment monitoring means here how this IoT are playing role, because the equipment is working in good condition means no issue. But suddenly the farm equipment means your tractor, maybe your tractor or any other agriculture related equipment, suddenly the equipment is faulted. What will happen? Production will stop, right? Definitely, if you are not properly collected the particular fruit or something, it will spoil in the land itself. So one thing maybe you just say okay, the tractor or agriculture equipment is faulted, but you have to predict the fault before it is occurs. This is for farm equipment monitoring. We are monitoring the equipment also, whether it is a good condition or not. Suddenly it should not get faulted. So whole thing will be wasted. And maintenance, you are properly, whenever you are not using the equipment, you have to maintain that equipment or the tractor or anything properly. So remote operation means you can control, you can turn on the motor remotely, you can turn off, or you can do everything remotely. Monitoring of the agricultural land remotely, plant remotely. As I told you, supply chain management. This is the important part. Now our local farmer and foreigners, they are maintaining the supply chain very good, because they are having huge amount of land. They are running the agriculture like an industry. We are not running the agriculture because we have small lands. The agriculture, what you can say, our farmers does not have big lands. They cannot use big agriculture equipments. You can see in some videos I have, you can see lots of agriculture equipment which is in the size of this room itself. Half of the size of the room, agriculture equipments. Our farmers cannot afford it. But in the foreign countries, the farmers are having thousands of acres. So they are running that farmlands as an industry. So here they are maintaining supply chain properly. Here our farmers, they don't know the demand in the consumer side. When there is demand, they are putting the plant in the action. When it is grown up, there is no demand in the market. So they will be in the loss. That's what is happening really here. So these are the things we already discussed. This robotic arms can be used for collection of vegetables or remove the damaged vegetables. Collection of what you can say, ripped, what you can say, or you can say spraying of fertilizers. Everything it can be used. And drones also can be used to monitor agricultural lands as well as fertilizer spraying and all. For that purpose, you can use. As I told you, it's a remote sensing. So you will have a lot of sensors in the land. It can be used for monitor and adequate action. So mainly the challenges, particularly I don't know about foreign countries, but India we have lot of challenges for the smart agriculture because as I told you earlier, the land is very less. The investment will be very high if you are going for smart agriculture. That's the first thing. And our farmers are not technology equipped. They cannot easily understand the technology. So we have to make them to understand the technology. That is the second thing. And time to market. That is the third thing. You have grown up the vegetables or any fruits or anything, but time to market is important thing. So already we discussed the automotive perspective. One of the important automotive role in the agriculture smart agriculture is tractors, the harvesters, sprayers, but tractors are playing an important role. So they have to be nowadays, John Deere company. Their vehicles are internet connected. All the vehicles are they connected internet. They are autonomous. You can easily control the vehicles. Even sitting in your home, you can easily control the vehicles. More autonomous. These John Deere vehicles and all. So traditional vehicles and all, mainly they are mechanical and they are operator dependent. There will be an operator. He is going to control the vehicle. But nowadays, all are IoT enabled. You can remotely control the vehicles. What is the speed? What is the torque needed? Everything can be controlled. What is the actual condition of the vehicle? Which direction it has to go? Everything can be controlled. And it can be used for data collection also. It can be used for the data collection, and you can have lots of data. That data is called big data. The more you have data, the more you can predict the future. Always the future, or you can say prediction, or you can say predictive maintenance. As I told you, now you have an equipment. This equipment is going to fail. How you know that? You should have history of data. The more data you have, more you can predict accurately. That's the thing. And it can be used for decision making tools also. When the equipment is going to fail or when it is going to be done, certain actions, it can be used. So these are the different parts. That is, we will have sensors. Sensors are like our eyes and ears. Okay? There will be a camera. That will be your eye. There will be a lot of sensors. That will be your ears. So all these sensors are your eyes and ears. And you can say you have GPS, geofencing, real-time communication. The real-time communication is through the internet. This is like a nerve system. Whenever there is something, your hand or eye is experiencing, sensing something, your nerve system is immediately taking action. Similarly, here the sensors and actuators will be activated based on the real-time conditions. The brain of the there will be a controller, definitely. There will be a controller in the vehicle. The controller will do this, your brain, roll of the brain. So what you know that autonomous means? It is self-driving tractors, harvesters and spray that they all do the precision. Precision can be maintained using this GPS and IoT's navigation, and with the help of that, the real time upstairs can be done. Here, I told you all the John Deere vehicles are internally connected. That is vehicle to vehicle, they are connected. V to V. All the vehicles are interconnected. Right? And V to I. What is V to I? V to vehicle to infrastructure. What is vehicle to vehicle and vehicle to infrastructure? What is the infrastructure means? You have two vehicles. If they two are connected, the vehicle to vehicle. In a network, you have a network of vehicle, and you have a centralized system also. Somebody is sitting in a lab, they are controlling the vehicles. Then it is connected to the infrastructure also. And it can be used for remote diagnosis, the tracking of the vehicle. See, it's not simple thing, man. Like in your Facebook or Insta, you are putting some information. This is just like a fun thing for you. But the information is connected, or lots of data you are sending to their server. Similarly, John Deere is collecting so much of data from the farmers. Every vehicle is collecting some data, it is going to the John Deere. So the farmers' information, everything is collected. So this can be used for in a positive way or in a negative way. Because the company is having all the information about the agricultural lands of the farmers. Right? So it's useless. Just like your social media, a social network. That's why I am telling, if you use something very advanced, there is good as well as there is a bad. We will see first only the good thing, but the bad will come in. Because these are the negative things about the advanced technologies. You are giving all the information about your land to someone. They are collecting for years and years. That could be a dangerous one in the future. So as I told you, this is one of the point I already told you. It's an embedded controller, everything will be there, yearly fault detection. The fault detection, definitely I am again telling, this can be predicted from your data only, history. Suppose your father is telling, hey man, if you are taking the bike, please put some 50 rupees petrol. It may stop in 10 kilometers or 50 kilometers or 20 kilometers. How he is telling? Or எப்படி சொல்றாரு வண்டி எடுத்துட்டே ஒரு 20 கிலோமீட்டர் வண்டி நின்னுட்டா பெட்ரோல் போட்டுக்கடான்னு சொல்லி எப்படி சொல்றாரு உங்க அப்பா உங்க ஃப்ரெண்ட் சொல்றாரு எப்படி சொல்றாரு the history of data, history of usage of the data. Always understand prediction comes from your history of information only. The more data you have, you can precisely you can predict the future. Okay, that's what the role of big data. So all the companies looking for the big data only. All your previous posts in the social media network will predict the nature of you, how you are going to respond in the future. Similarly, right? Here in particular I am telling, reduce the downtime. This is also I told you. Downtime means what? When suddenly the equipment, the tractor is faulted, your manufacturing will stop. Your manufacturing will stop now. That's what the downtime I am talking about. All your investment will be wasted if you are not yield is not properly connected at the right time. So we have to avoid sudden downtime. So yearly fault detection is one of the things. Before it fails, right? Before it fails, you have to predict it, and whenever your equipment is not in a use, you have to do maintenance, right? You have to properly do the maintenance. So if these are the certain agriculture overcoming. So these are the key components of the automotive where IoT smart farming. That is the connected machinery. Connected machinery, connected vehicles. Different vehicles are interconnected, right? Network of sensors. Sensor fusion you might be heard about. Sensor fusion means what? You have more number of fusions, more number of sensors. You are not taking the decision from only one sensor. N number of sensors you are using, maybe temperature sensor, pressure sensor, humidity sensor. Different sensors are interconnected. From different sensors perspective, you are taking the decision more correctly. So yeah, that's the thing. Edge computing units. You might be heard about ESP32. You are EC student, na? ESP32 you might be heard about. Arduino you might be heard of. Raspberry Pi you might be heard of. Right? These are all edge detecting. Because they are edge means before you pass something to the internet, you will pass something in the network. Right? Internet also, in your laptop also you can process. Edge means it's a intermediate device. An Arduino can be act as a edge device. ESP32 can be act as a edge device. Right? From your sensor, the information will go to the ESP32. From the ESP32 it will be connected to cloud. Anyone was working with that? Simple projects? Then cloud platforms. The data is coming from the edge device, it is going to the cloud. Cloud, we are storing so much of data. The end of the day it is coming to the user interface. Because in the cloud, all the data will be processed. Then the results you can see in your GUIs, in your apps. What is the real condition of the plant? What is the humidity? What is the temperature? Whether I have to irrigate to the particular plant. This all the thing will be processed in the cloud and it will come as a result as a GUI in your mobile or in the laptop. So as I discussed, extending the V2X and real-time data sharing, the hybrid networks. We are not using purely LTE or 5G or LoRa band, integrating different networks. So this is all about telematics. So what are the different components when you are this is again the same thing what we have discussed, sensors, then cloud, then connectivity modules, something like cellular, satellite, LP-WAN. The purpose why we need to go for telematics. Sitting in your home, you can monitor your plant, everything, and you can do the predictions. You can monitor all your plants and the then precision farming. Again, how we are using the telematics for the edge computing, drone connectivity, blockchain. So before telematics, how we are using? We were using manual tracking of equipment, reactive maintenance. That's what I'm telling. Reactive maintenance. When it is get faulted, then we will do the maintenance. Predictive maintenance, it's opposite to word, right? Reactive maintenance and predictive maintenance. Before it fails, you will do the maintenance. You can avoid downtime. That's the thing you have to understand. So uniform application rates, but this is the important thing. We don't know whether the plant is needed water or not, but we will do watering. Whether the plant is needed the fertilizer or not, we will do fertilizer. So the smart way of agriculture is this: the drones will monitor all the plant's condition. Whether the plant is needed fertilizer, the fertilizer will be sprayed. Whether the water is needed to the particular plant, the water will be sprayed. So now, after telematics, real-time tracking of all the plants, predictive maintenance, that's it, what your reactive maintenance and predictive maintenance. Variable data application. Why need to spray and fertilizers everywhere? Wherever it is needed, I will do it. Right? Complete operational visibility from anywhere. Anywhere, that's anywhere. Sitting in your home, sitting in the traveling in a flight or traveling in a train, you can do it anywhere. These are certain challenges we are having in the telematics. So I will finish with this forming of reimagined. Farming is reimagined with the help of autonomous machines. So the self-operating is definitely there will be AI. Without AI, it cannot go for self-autonomously. Nothing is without AI, right? And IoTs. So definitely you need these things: sensor integration, connectivity, and cloud platforms. So wherever you are using this autonomous seeding, spraying, adjust rates based on the sensor feedback. That's what I told you. The spraying and the feeding, everything will be based on the condition, whether the plant is really needed or not. That's what the feedback is coming from the sensor, right? Then smart harvesting. This is what I told you. Smart harvesting, whether the fruit is really ripe or not. Definitely you need some image processing, right? So field mapping, navigation, this is used for the path. It has to travel in a defined path. Your autonomous vehicle just like the different path. So you need GPS is needed, then field path is needed. Why we need to go for autonomous vehicles? So labor and cost reduction, enhance the productivity, then environmental benefits, data-driven decisions. I just go finally. I cannot handle this right now. So you just need to understand what is the government is doing. This is the dedicated prepared slide for you people. Government is initiated a program. It is digital agriculture mission. So whatever the points I discussed it before, now India has also initiated all the points. Whatever the point I discussed is happening in the foreign countries. Now Indian government is also initiated. It is also doing everything, whatever thing they can do. Right? This is the initiative by Government of India, modernize and revolutionize the agriculture sector through digital technologies. So what are the things? This is the amount of money invested and what are the plans they have in the, what are the things? See, precision farming is there, smart aggregation is there, AI-based crop monitoring is there, the blockchain is there. So the contents I discussed everything currently in foreign countries, but Indian government also initiated that. So in future, our farmers also will get benefit out of it. That's the thing I want to tell you. Everything is related to that vision only. So in India, what is the challenge? I told you. High initial investment, limited digital literacy. I told you our farmers are that much not literate for the technologies. Then poor internet. Of course, this is really important point. Poor internet connectivity in villages. This is really because IoT is not much without internet. You know that. And we have the old way of farming. We have resistive to the new technology. Our farmers definitely they will be resistive. These are the things. So government has to start support. Private sector also seriously has to involve, and they have to train the farmers. This is the future of our agriculture in India. This is the last slide I want to tell you. Okay, if agriculture goes wrong, nothing else will have a chance to go right. You know who is famous Swami, right? That's all from my side. Thank you for your patience listening. Okay. Really, I appreciate your patience. Okay? Thank you for the cooperation. If you have any queries, you can ask.
Thank you, sir, for sharing your knowledge with us. I request Dr. U. Jayalakshmi, Head of the Department, to facilitate